At time 0, Cheryl deposits X in an account that credits interest at annual effective 7%. At time 3, Goma deposits thousand into a different account that credits simple interest at Y%. At time 5, the annual forces of interest on the two accounts are equal, and Gomer's account has accumulated to Z. Calculate Z. So let's first look at Cheryl. She deposits X in an account at annual effective 7%. So that's just the compound interest. And we are interested in, first of all, we're interested in the forces of interest because we are told that at time 5, the forces of interest on the two accounts are equal. So we know that for an annual effective rate of 7%, which actually is annual compound interest, the force of interest is constant and it's ln 1 plus I. So delta would be ln 1 plus 0.07, and it would be 0.06766. So maybe we can even mention a line here. We know that for a constant annual effective rate of interest I, which is in fact, so let's correct this. Okay, which is actually compound interest. Because anytime it's a constant effective rate, it's compound interest. It's actually compound interest. The force of interest constant and is, so the force of interest is ln 1 plus I, and that's only for annual compounding. ln 1 plus I. And so Cheryl's force of interest would be ln 1 plus 0.07 equals 0.06766. Now for Gomer, we have to do more work because Gomer has simple interest. And so for Gomer, we use the general formula for force of interest, which is A prime T over AT. And now Gomer has simple interest. And so we know the amount function for simple interest is P times 1 plus IT. So delta T would be the derivative of A prime, which would be just P. Okay, first we substitute the fact that I for Gomer is Y%. And so we substitute Y over 100 for I. So the amount function becomes 1000, 1 plus Y over 100T, because the principal was 1000 and interest rate was Y over 100 for Gomer. And so when we take the derivative now, so again, maybe just rewrite again that this is A of T. So when you take the derivative of this with respect to T, remember Y will be a constant when the derivative is done with respect to T. So this 1000 is a multiplied constant that stays. The derivative of 1 is 0. And Y over 100 is a constant. So the derivative of YT over 100 is just Y over 100. And delta T therefore will be A prime over A. A prime is 1000 times Y over 100. A of T was 1000 times 1 plus Y by 100 T. And when you take the common denominator here, you get 100 plus YT over 100. And these thousands cancel out. And then these hundreds will cancel out and you'll just get y over 100 plus yt. So that's a general formula for Gomer's force of interest at time t. We are interested in the force of interest at time 5 because we're told that at time 5 they are equal. Now, before that, we have to realize that Gomer deposited at time 3. So time 3 is like acting as time 0 for Gomer. So by time 5, 2 years have elapsed on his account. So we actually need his force of interest at time 2, because time 2 for Gomer is time 5 from the beginning. Gomer starts at time 3. So when you substitute 2 here, so actually delta 2 for Gomer will be the force of interest at time 5 for Gomer. So you substitute t equals 2, so you get y over 100 plus 2y. And now we are told that the two forces of interest are equal at time 5. And Gomer's. So let's see. So let's add on here to get, so to get Gomer's force of interest at time 5, we need his force of interest at t equals 2. So delta 2. Okay. So then we set Gomer's delta 2, which is actually force of interest at time 5, equal to Cheryl's constant force of interest. And we next cross multiply here. And after we do the distribution and collect the y terms and then divide by this coefficient, we get y equals 7.825. So the eventual goal was to calculate z for Gomer. Z was the amount for Gomer at time 5. So again, time 5, the universal time 5 is actually time 2 for Gomer, because Gomer, as we've said before, starts his function at time 3. So we actually need a of 2 for Gomer. So a of t for Gomer was 1000 times 1 plus y by 100t. So we substitute t is equal to 2 here. Actually, let's copy it. A of t is this, so a of 2 will be 1000 times, so just substitute the y value that we calculated, which was 7.825, and t is 2. So that comes out to be 1156. This rounds to choice A.